Most people assume fresh is always better. It looks better, feels better, and seems like the more natural choice. But when it comes to blueberries, the science tells a more complicated story. And by the end of this video, you'll never look at the frozen section the same way again. Welcome to Ingredient Verdict, where we examine one ingredient at a time, no hype, just the evidence. Today we're looking at blueberries, but not the question you think. It's not whether blueberries are good for you, it's which blueberries you should actually be buying. And the answer involves a finding that surprises most people. The freezer section may be outperforming the produce aisle. Quick note before we start. This video is for informational purposes only and does not constitute medical advice. Always consult your healthcare provider before making significant dietary changes. Let's start with the basics. Because not all blueberries are the same species. When most people in North America and Europe think of blueberries, they're thinking of high-bush blueberries, Vaccinium corymbosum. These are the large, pale blueberries that dominate supermarket shelves. They were selectively bred for size, uniformity, and yield. They travel well, they look good in a punnet, and they're genuinely nutritious. Wild blueberries are a different species. North American wild blueberries, Vaccinium angustifolium, are the small, intensely dark berries that grow across Maine, eastern Canada, and parts of the northern United States. They're not farmed in the traditional sense. They grow naturally across open barrens and are managed rather than cultivated. They're almost never sold fresh in mainstream supermarkets. European bilberries, Vaccinium myrtillus, are what Scandinavians call blåbär. They're botanically distinct from both and worth a separate mention. Unlike high-bush blueberries where the anthocyanins are concentrated in the skin, bilberries contain anthocyanins throughout the entire flesh. That matters, as we'll explain shortly. Now for the anthocyanins, because this is where the real story is. Anthocyanins are the compounds responsible for the deep blue and purple pigmentation of berries. And they're the primary reason blueberries have attracted so much research attention. Anthocyanins belong to a class of plant compounds called flavonoids. They work through several mechanisms simultaneously. They act as direct antioxidants, neutralizing free radicals that damage cells and DNA. They modulate inflammatory pathways, particularly by inhibiting NF-κB, one of the master regulators of the body's inflammatory response. They appear to cross the blood-brain barrier, which is why cognitive research on blueberries has become one of the most active areas in nutritional neuroscience, and they interact with the gut microbiome. Research suggests anthocyanins selectively feed beneficial bacteria while inhibiting pathogenic strains. The specific anthocyanin profile differs between blueberry varieties. Wild blueberries and bilberries contain a broader range of anthocyanin subtypes than cultivated varieties, which may matter because different subtypes appear to have different biological activities. Research suggests that diversity of anthocyanin types, not just total quantity, may influence health outcomes. Research consistently shows that wild blueberries contain significantly higher concentrations of anthocyanins than their cultivated counterparts. Studies comparing wild and cultivated varieties have found 2 to 3 times higher anthocyanin levels in wild fruits, depending on the varieties compared. The reason is straightforward. Smaller berries have a higher skin-to-flesh ratio. And since anthocyanins in high-bush blueberries are concentrated in the skin, smaller berries mean more anthocyanins per gram of fruit. Bilberries, the European wild variety, have an additional structural advantage. Because their anthocyanins are distributed throughout the flesh rather than just the skin, they maintain their potency even when the skin is broken down during digestion or cooking. Now for the finding most people miss, and this one genuinely surprised us. Most people assume that fresh blueberries are nutritionally superior to frozen. The logic seems obvious. Frozen means processed. Processed means degraded. but the research doesn't support this assumption. And in several important ways, it actively contradicts it. Here's why. Fresh blueberries sold in supermarkets are typically picked before full ripeness to survive transportation. They then spend days in transit and on shelves, during which natural degradation continues. Anthocyanins, vitamin C, and other bioactive compounds begin to decline from the moment of harvest. Frozen blueberries are typically harvested at peak ripeness and flash frozen within hours. The rapid freezing process locks in the nutrient profile at maximum concentration. A peer-reviewed study found that frozen blueberries retained significantly higher levels of certain antioxidants compared to fresh blueberries that had been stored for several days. There's an additional finding worth knowing. The freezing process causes ice crystals to form that physically break down the cellular structure of the blueberry skin. This cellular disruption may actually make the anthocyanins more bioavailable, more accessible for the body to absorb. We'd call this promising rather than definitive, but it adds an interesting dimension to the frozen versus fresh question. One important exception: vitamin C is sensitive to heat, and some degradation can occur during blanching. However, blueberries are generally not blanched before freezing, unlike many other frozen fruits and vegetables. This means the vitamin C concern that applies to frozen broccoli or frozen peas largely doesn't apply to frozen blueberries. So, fresh blueberries eaten the same day they're picked? Excellent. Fresh blueberries that have spent 4 days in transit and 2 days in your fridge? A frozen bag of wild blueberries may actually be the better nutritional choice. What does the health research actually show? Cardiovascular health has the strongest evidence base. Multiple human clinical trials and large epidemiological studies have found associations between regular blueberry consumption and reduced blood pressure, improved lipid profiles, and reduced markers of arterial inflammation. A 2025 review examining anthocyanins from Vaccinium species and cardiovascular disease found consistent cardioprotective effects across human observational and clinical research. Cognitive function is the area generating the most recent research interest. Studies have found associations between regular blueberry consumption and improved memory, processing speed, and executive function, particularly in older adults. The mechanisms being studied include anthocyanins' effects on neuroinflammation, blood-brain barrier function, and cerebral blood flow. Blood sugar regulation is another area with meaningful human evidence. Research suggests that blueberry anthocyanins improve insulin sensitivity and reduce postprandial glucose response. This effect appears to be mediated partly through inhibition of alpha-glucosidase, the same enzyme mechanism we discussed in our maltodextrin video. Anti-inflammatory effects are consistent across the literature, but mostly from in vitro and animal models. The human clinical evidence is more limited. We'd call this mechanistically well-supported, but not yet definitively proven at typical dietary doses. Now, for a practical note specific to European listeners. Swedish and Nordic vilda blåbär, European bilberries, deserve special recognition. The fact that their anthocyanins are distributed throughout the flesh rather than just the skin means they retain their potency across a wider range of preparations. Research on bilberries specifically has found promising effects on eye health, blood sugar regulation, and microbiome composition. If you have access to fresh or frozen bilberries, they represent one of the most nutritionally dense berry options available in European markets. Now for something most blueberry articles don't cover: absorption. Eating anthocyanin-rich foods and actually absorbing those anthocyanins are two different things. Anthocyanin absorption is relatively low compared to some other polyphenols, and the picture is more complex than most sources suggest. Research indicates that a significant proportion of ingested anthocyanins passes through the small intestine without being absorbed. Most reach the colon, where gut bacteria metabolize them into smaller compounds that are then absorbed and may account for much of the biological activity attributed to anthocyanins. The exact proportion absorbed varies considerably between individuals, and between different anthocyanin types, which is part of why gut microbiome health matters so much for getting the most out of blueberries. People with a more diverse microbiome appear to metabolize anthocyanins more effectively and produce more of the bioactive metabolites linked to health benefits. Some research suggests that consuming blueberries alongside food, including sources of healthy fat, may influence how anthocyanins are absorbed and metabolized, though findings are mixed and more human studies are needed. A practical approach is to pair blueberries with Greek yogurt, nuts, or nut butter, which may improve bioavailability while also making for a more balanced and satisfying meal. The second factor is heat. Prolonged high heat degrades anthocyanins, but brief moderate heating, as in a warm compote or lightly cooked oatmeal, appears to cause minimal loss and may in some cases improve extractability from the cell matrix. We'd call the absorption research promising and growing. There's enough evidence to make these practical recommendations worthwhile, even as the full picture continues to emerge. So here's our verdict. For maximum anthocyanin content, wild blueberries or European bilberries outperform conventional high bush varieties. The difference is meaningful, not marginal. For fresh versus frozen wild blueberries are often the better practical choice for most people. They're harvested at peak ripeness, flash frozen quickly, and research suggests their anthocyanin content matches or exceeds fresh supermarket berries. For brain and cardiovascular health, the evidence base is strongest for regular consumption over time, not occasional large amounts. A handful of frozen wild blueberries in a daily smoothie or with oatmeal is more effective than an occasional fresh punnet. For maximizing absorption, pair blueberries with a source of healthy fat. Greek yogurt, nuts, or nut butter may improve bioavailability, and a diverse gut microbiome helps too. Another reason the gut health content we cover on this channel connects directly. For cooking, adding blueberries toward the end of cooking preserves more of their antioxidant content. Brief, moderate heat is fine. Prolonged high heat is where losses become significant. The practical bottom line: keep a bag of frozen wild blueberries in the freezer year-round. They're typically cheaper than fresh, available regardless of season, and may deliver more of the compounds you're actually buying blueberries for. That's our verdict on blueberries. Bottom line, in this case, the freezer section wins. Read the label, not the marketing. If this was useful, subscribe. In every video, we examine one ingredient. No hype, just the evidence. What ingredient would you like us to examine next? Drop it in the comments below. Next up, we examine titanium dioxide, the food additive the EU banned while the rest of the world hasn't. See you then.